All right, thank you so much all for joining for this lecture again. This is going to be for paper second, and today's topic is very important, not from only the paper second, but for the point of view of a paper one as well. I have always told you that whatever you studies for business statistics, this is relevant and important for paper one as well, because in paper one you have to go through from research methods, research methodology. This is the second subject under paper one, and this is very important. Okay, so my today's lecture shall be made understandable to only those students who have already gone through from prior two lectures. So I have to ask a simple questions to you all. You have to reply in yes or no, then I'll be able to know that whether you are consistent or not, because after that I have to manage your time as well, because if I know your problems, what problems you are facing, like is this the time management or schedule management or anything, then I can suggest you some ways to improve your time management or to improve your schedule so that you can study better. Okay, so the question is very simple. How many of you have gone through from the video of measures of central tendency, skewness, and curtices? Just reply in yes. Just reply in yes if you have gone through. My question is, do you have gone through from the video of measures of central tendency and skewness and curtices? How many are you able to listen to me? Okay, yes. How many of you have gone through from even live video or recorded video, anything? Okay, okay, all right. All Navneet, do you have gone through? I think you were there when the live lecture was being taken. All right, I got it. Okay, so I like the consistency of the students. The reason being, the statistics is not a completely theoretical subject. Okay, like there are some subjects which are very interrelated with concept matters. Okay, let me tell you which are these are like statistics. After that, this is financial management. This is very important. And after that, there is managerial economics or economics for business. Okay, so these are some subjects, or accounting as well. The topics of these are very interrelated. Okay, so if you have gone through from one live or a recorded video, only then you shall be able to understand the next one. Okay, so this is why you have to be very in touch with each and every topic being taught by us. So now I'm going to share the screen so that each and everything is visible to you. This is going to be part first of regression and correlation. Again, before starting, would like to take your quick confirmation. Is everything okay from my side? Should I start? Are you able to listen to me completely? All right, thank you so much. I have got the confirmation. So now I am just sharing all the matter I have prepared for you, and only these shall be relevant for you. You are not supposed to go through from big books like what you have already done in your graduation, undergraduation, and post graduation. Okay, so this topic is somewhat big. Okay, it included correlation and a regression analysis, the analysis of two variables. Okay, analysis of two variables in combination, two or more than two variables in combination. So as you know that this could not be completed in a single day, so that's why parts have been divided. In part first, we shall study about correlation. Even in this lecture it is not completed, then we can take next lecture even today. Okay, then the credential will be sent to you again. So this is for correlation analysis. What is correlation? Correlation is simply an analysis of a covariation between two or more variables. Okay, this is not of my style, as you know that just reading line, I have to clear your concepts. I have left all this slide completely blank. Variables you have understood if you have gone through from the uh, first video lecture, measures of a central tendency. I told you about variables. Variable means anything which varies in data points. Anything. Okay. Anything means height of students, marks of students, weights of students. Okay. Weights of students. Okay. Brands of number of brands under us, different brand width or brand line. Okay, so these are all the data points. Here comes someone's height can be 5 feet 5 inches, 5 feet 6 inches, 5 feet 8 inches, 9 inches. So all these are data points of a variable, and this is called a variable. So this is a variable. Okay, this is variable 1, this is variable 2, this is variable 3, this is variable 4, and variable can be anything in the world. Okay, and when we relate two variables with each other, this is known as correlation. When we correlate, so now you would be able to understand this line. When you make the covariation or when you correlate between two or more variables, this is known as correlation. Very simple example I am giving you. I am writing here a diagram or plot. Simple. There are two variables. This is 0. This is the centrality of each and every data curves. This is x. X is first variable. Suppose this is height. Okay, height's data point have been given here. Height's data point have been given here. Then this is y. This is second variable. This is weight. Okay, this is weight. Weight's data points have been given here. Okay, these have been given in there. We make the plotting of these two. Okay, we try to make the relation. How do they relate with each other? Okay, how do they relate with each other? Or there can be some more data points for heights or this, and this is just a usual example I am giving you. Okay, so if you plot the data points, okay, for both the variables, if you plot the data points as per their occurrence, okay, and when you match these data points, so this kind of a study, this kind of a complete study is known as correlation of two variables. Okay, how do they correlate? Correlate means how do they combine? Simply, how do they co-vary? Co-vary means how do they vary? How does the first one vary and how do the second one vary? Vary means variation. Variation means a state of being changed. Okay, so this is the complete concept of correlation. In the one line, I have told you the explanation, and I have taught you in a way that upcoming slides are going to be very easy for you right now. Now, let me tell you why you have to study correlation. Why do you have to study? Because if you know the reason why this is for me, then only then it can create interest in your study. Okay, so why to study correlation? It measures the extent of relationship between two variables. It can tell how height is related to weight. Okay, it can tell this. Then it can predict about future. If we know the data points of heights, then we can make a prediction about weight. This is very simple example. Then we can know the value of another variable. Same this line. If we know the data points of height, then to some extent, in the right figures, we can get the data points of weight if we have previously made the correlation between these two variables. Then it contributes to economic behavior, because nowadays researches are being conducted using correlation at a wide scale, like for GDP, like for FDI, like for FIIs, then institutional investors only. Then number of things are there, interest rates are there, bank rates are there. Okay, so these are all the variables. These are all the variables, and studies are being conducted for finding their correlations with each other. And after finding the correlation, you can get better prediction about their future occurrence. Okay, so in this way, it is said that correlation contributes to economic behavior as well, because this is a very relevant point to study. And I believe that statistics or economics should be everywhere, and it should be taught to each and every student of irrelevant to their area of study, whether they belong to any stream. Okay, because these are important, only then you can get the basic knowledge and understanding about the economies. Okay, so these are the things you are lucky enough that you know how the things are related to each other. This is a mathematical concept. Okay, it makes it easy to combine or relate two variables A and B. Okay, so this makes it possible to find the value of B on the basis of A. This is the only one. This along with the regression as well, that we shall study tomorrow. Okay, so next significance, the technique of ratio of variation and regression analysis depend totally on a coefficient of correlation. That means each and every study about the statistics, after, if you are going to make the combination between two variables, then correlation is the base of everything, because each and everything, ratio of variation, a regression analysis, everything depends upon correlation only. So this is why you should study correlation. So I have cleared your concept in this way. Now we have to go to the types of correlation. I hope that you would have understood this concept. Okay, this concept was very important to understand. If you have understood this example, that how you can correlate one variable with another variable, then this lecture is going to be very easy for you. I just believe me that this is very important and very easy for you right now. Types of correlation, first is positive. If with the increase in one variable, the other variable also increase, then this is positive correlation. Okay, so see this, as the x is increasing, y is also increasing. This is why there is a straight line going here. So this is called positive correlation. That simply means if increase in one variable is followed by increase in another variable, this is positive correlation. And if the vice versa, then this is negative correlation. This says that if increase in one variable result in a decrease in other variable, then this is negative correlation. Okay, this is negative correlation. One is increasing to this side, but the other one is decreasing to this side. So this is why the line is like that. Line of correlation is like that. So in this way, we can conclude that if one variable is increasing, but the other one is decreasing, this is negative correlation. And the last one, or the third one, zero correlation. If increase or decrease of one variable do not affect another variable, then this is zero correlation. Okay, this means no relationship between variables. Okay, can you make the relationship between your marks and height of your sister? You can never make. Okay, you can never make their relationship. Okay, this is a completely spurious relationship. Okay, so some variables cannot be interrelated to each other, although you can find the correlation value of these if you have the data points, but using these variable and finding their correlation is of no use. So if change in one variable doesn't cause change in another variable, then it results in zero correlation. So zero correlation is like that. This is completely like that. Okay, so these things you have to go through. Each and everything have been defined in the notes in a very elaborated form, but you must clear your concepts here. Okay, so the next is simple correlation. If we are finding the correlation between two variables only, then this is called a simple correlation. Okay, when there are only two variables and we study their correlation, this is a case of a simple correlation. So very simple to understand. Multiple, if there are more than two variables, suppose there are five variables, and we are studying, okay, we are studying one variable and its a relation with combined four variables, then this kind of correlations is known as multiple correlation. Okay, suppose we have 10 variables, we are studying the behavior of one variable on the basis of 9 other variables, then this is known as case of multiple correlation. And this is widely used in researches. Simple correlation is not used widely that much. Okay, if you want to go through from this as well, if you are a PhD research scholar, I can teach you these concepts as well, because I have taught in my to my PhD level students as well. So these are multiple correlation. Then partial correlation means if there are more than two variables, okay, suppose variable A, B, C, D, but you are finding the variable at one time for only two variables. Like I am finding the correlation of A and B only. After that, I am finding only B and C. After that, I am finding the correlation of only C and D. After that, only A and D. So when there are more than two variables and the relationship between any two variable is studied assuming other variables as a constant, this is partial correlation. Means we ignore the other variables. If there are three variables, we are ignoring C, finding their correlation only. After that, we are ignoring A, finding correlation of B and C. This is the case of a partial correlation. Then this is total correlation. If we are going to find the correlation of each and every variable together, not making anything constant. If there are 10 variables, finding programmatically the correlation of all together. This is known as total correlation. When the correlation between the variables under study is taken together at a time, this is total correlation. Very simple to understand. Then linear correlation, if the change in one variable causes a linear change in another variable, okay, this is known as linear correlation. Okay, its definition is this is the ratio of a change between the two variables either in the same direction or in the opposite direction. Okay, let me tell you how this is a linear. This is the case of a linear correlation because it is representing a line. That means there a ratio of a change of X and B is almost equal. This is why it is making a straight line. Okay, this is called linear correlation. And curvilinear, when change the ratio of X is not equal to change in a ratio of Y, and it shall make different shapes like this, like this. This is known as curvilinear correlation. Okay, and this is saying if a graphical representation of two variables shows curved line means it can be like that, it can be like that, it can be this or anything. Okay, but it is not the straight line. If this is not straight line, then this correlation is known as curvilinear correlation. And these were some of the types. You have to understand these. Now we shall move further how to compute correlation. Okay, now mathematical formulas are about to come, although some of the students of our batch personally know me, and I believe that they were very sound in solving practicals, but do not go for these. Okay, because they in just 2 marks questions, they are not going to ask you to find the value of correlation. Okay, because they are not going to give you any kind of paper by which you can make the table presentation and you can find the correlations. Do not waste your time, just understand the concept and subject matter. Okay, then, and whatever the notes are with you, you have to go through from these, and just for your own knowledge and for concept clarity, you can solve at least one numerical from all the concepts. So methods of computing coefficient of correlation. The first is a scatter diagram. Just make a scatter diagram. What is scatter diagram? This is simple. This is simply this. This is a scatter diagram. That means you have to show data points of each variable separately, and then you have to represent these in a line. This is known as a scatter diagram. This is the first way to find correlation. Okay. So what is scatter diagram? When you make first variable on x-axis and second on a y-axis, and then you make some dots and you try to print a line between the dots, then this kind of diagram is known as a scatter diagram simply. Okay, so this is the first method for knowing about the relationship between variables. So scatter diagram or a dot diagram is a graphical device for drawing certain conclusion about correlation between two variables. You would have understood this completely. Just make the dots of the variables and try to find their relationship. This is a scatter diagram. Then here comes the next one. This is after types. This is simple correlation, partial linear. We have gone through scatter diagram. This is graphic method. When we show graphically all the data points, okay. So in this way, we have separately joined all the dots of a single variable by single line, okay. So that may represent to X only, and this may represent to Y only. When we make separate lines for both of the variables, so this diagram is known as a graphical representation method for knowing about the variables. Okay, so this is also known as a parallelogram or simple graph method. Very simplest method to determine the presence of a correlation. And how this is done, two variables are plotted on a graph paper, and we shall get two curves individually for X and Y. And by looking at these curves, we can get to know if they relate or not. So this is known as the graphic method of finding correlation. So now we have to move further for the mathematical methods of finding the presence of the correlation and the level of a presence of a correlation. Okay, so this is the first method. And before even starting this, I must tell you, you would have gone through in your textbook like direct method, then shortcut method, then step deviation method, then a lot of things like these. You are not supposed to remember each and everything. Whatever is relevant has already been given to you. Only one formula would be sufficed. You have to clear your concepts only. They are not going to ask you to solve biggest question for just 2 marks only. Okay, whatever is relevant we are giving to you. You have to clear your concepts, and what else is necessary, which I have not written in all the slides because this is not of my nature of a teaching. Everything has been written in a very clear format in the notes. And if you have gone through from the live videos or the recorded videos, reading all the notes shall become very easy for you, and I believe that. For the mathematical methods, the first is for Carl Pearson's method. Reputed statistician in 1890 constructed the formula for finding the correlation between two variables. This is popularly known as Carl Pearson's coefficient of correlation or product movement coefficient. How to find? So this is, they told that you have to find the covariance between X and Y, then standard deviation of X multiplied by standard deviation of Y. Okay, so this is how you can calculate. This is again the defined version of this formula, and this is again the defined version of this formula. You can find these values. Okay, very clearly these have been written. Sum of smaller X and smaller Y represent covariance. X represent the deviation, mean deviation for X series. Smaller Y represents the mean deviation for Y series. This represents the standard deviation of X, and this represents the standard deviation of Y. So only this would suffice, although there are a number of formulas under different methods. Okay, and even they are not going to ask what is the formula under step deviation method. These kind of nonsense questions are not going to be asked, because in past 25 to 26 years, never in the history of the examination these have been asked. So important are the properties of a correlation. These are specifically known as Carl Pearson's coefficient, or the Carl Pearson's or the simple properties of a coefficient of a correlation. What are these? They says it lies between plus and minus 1. Okay, plus and minus 1. In case of a correlation is present, then the coefficient would be lie between this value. Okay, if this is absent, it would be 0 or none. 0, it would be 0 simply. Okay, then coefficient is based on measures of variations, as it take into account all items of a variable. That means all items has to be taken into consideration. Well, all values of x and all values of y should be taken into consideration for finding the correlation. Only then true value of a correlation can be found. This is the second property. The third one is coefficient measures both direction as well as degree. Direction means whether this is positive or negative or zero, and a degree means how much the correlation exists. Is this 0.23? Is this 0.57? Is it 0.98 or anything? So coefficient of correlation measures both the direction as well as the degree. Then if there is accidental correlation, this may lead to fallacious conclusions. That means this is a spurious correlation. This simply means if two variables are with the common sense cannot be attached together, you can find their correlation, but that would be nonsense correlation. Simply means marks and size of shoes in a size of shoes in a showroom. So marks and size of shoes do not have any kind of common sense relationship, but still you can find their correlations if their data points have been given. But that correlation will be a nonsense correlation or a spurious correlation. This is the fourth property. The fifth one is correlation doesn't prove causation, but it simply proves covariation. Understand it deeply. If we have make the relationship between height and weight, and we have got the positive correlation, it can provide us only the value of correlation. Okay, it can never provide us why this correlation exists. So that means it can never answer why. It can never tell us cause. It can never tell us cause why height is related with weight. It can only tell us yes, this relates. Then it is independent of a change of scale and change of origin. This is very simple. That means if any item is multiplied, deducted, plus or minus in the items of individual variables, it doesn't change the value of your correlation. So this is said it is independent of a change of scale and origin. Then coefficient correlation can be found by regressions as well. So this is a regression of x on y. This is a regression of y on x. When you multiply these and when you find their under root, that will be equal to the value of correlation. Okay, so from the basis of regression coefficients, the correlation can be found out. Okay, coefficient correlation work both the ways. Okay, you can find correlation of x on y, you can find correlation of y on x, value will be same. The last one, that was the last one. Now we have to go with the concept of a probable error. I have added this, okay, and I know that no one of you would know that this could also be the topic, probable error in the correlation. I'm 100% sure, but you have to go through. This is a very small and simple concept, okay, and you have to understand it as the way I'm telling you. What is probable error? This is a complete sample. This is a complete sample. Okay, complete sample, but we have taken complete sample of two variables, but we have taken only this and this part for finding correlation, and we have already found the correlation between these two. Okay, understanding me? This is the complete population or sample, and we have taken only these two parts and we have left all the other parts. Okay, and now, what is the probable error? Probable error defines the limit above and below the size of a coefficient determined, within which there is an equal chance that coefficient of a correlation of a similarly calculated from other samples will fall. Let us just understand this deeply. We have found the correlation from these two values only. We have left all. Probable error is the value which tells the above and below limit of this value at which the correlation of other samples shall fall. So this is very simple to understand. This probable error means a limit upper and lower limit of the correlation found for two variables. This limit defines at which the correlation of other variables may fall. So this is called probable error. Okay. This is the formula for finding, and you have to understand and you have to cram this in your mind. Okay. Because this is very important. It cannot be changed because this is none kind of logic which can make it shortcut. Okay. So you have to understand this concept I have already taught you. Second is coefficient of determination. This gives the variation. This gives the ratio of explained variance to total variance. Very simple to understand. Just read this line and make square of a correlation. Okay, suppose you have find the value of a correlation, make square of that. That will be coefficient of determination. Once this was also asked in the examination. This is coefficient of determination. This gives the ratio of explained variance to unexplained to total variance. Variance, if you want to learn from me, otherwise this is not needed. If you learn, variance means how much do data point vary. Okay, how much variation individual data points have with each other. Okay, how much variation is there. So explained variance divided by total variance is equal to coefficient of determination. Otherwise, just scare the correlation. That will be the value of a coefficient of determination. So after going through all these things, we have to understand about rank correlation. This is Pearsman's method. Although numericals are not necessary, but formula, understanding formula and just cramming this is very necessary. This was devised in 1904 by Professor Charles Edward Spearman, and they told that on the basis of ranking of different items of the variables, you can find this. You can find the coefficient of correlation. And this is a non-parametric approach. This is a very important word I have taken here. When we shall study about the probability distribution, we shall study these in details. Some tests are parametric, some are non-parametric, and rank correlation falls in this category. So this is important. This line was important from my side. Okay. So how to find rank correlation? This is the complete formula of that. You have to understand, you have to write this. These are just rank differences. Made square of these, n is number of a pair and again number of a pair, and you have to apply the BODMAS rule for solving this equation. And when you solve this you shall get the value of a correlation. Although there shall be not any kind of a practical, but just understand this formula. They can ask you this formula. Okay, because the question can be of match the columns. Some formulas will be given, some items will be given, and you have to match the columns. Which formula relates to what? Okay, so at that kind of levels, you have to understand these formulas. The last one is concurrent deviation method. So this method is also to find the correlation. This is simplest of all for finding coefficient of a correlation. Only what is required is the direction of a change, whether this is plus or minus, plus or minus, plus or minus, like 5, 6, 7, 8. Every time there is addition of one item, so these are increasing. So on this method, you can find the correlation. This is the formula for finding the coefficient of correlation on the basis of concurrent method. Okay, so this denotes to coefficient of correlation by concurrent method. C is concurrent number of concurrent deviation or positive signs. Okay, then n is number of items, and you can find this correlation value. So in this way, all in all, you have to understand each and everything. You have to go through from all the concepts given in the notes as well, because as per my system of study, I clear your concept so that it becomes easy for you to understand. Otherwise, this is a study of a complete 7 years. No one can study in 5 months only, if you are going through practicals as well. Okay, so whatever we have suggested, you have to go through from these, and every day we shall ask you whether you have studied or not, because I have to take care of personally. And in case you are facing any kind of issues like time management, schedule management, or anything, then you can simply ask to me. We have a lot of solutions. Genuinely, believe me, I have a lot of solutions for all these things. Okay, and I can suggest you some ways by which your study can become very easy, because your success is not your success, this is our success as well. So about the next lecture, it shall be intimated to you by tomorrow. And this was about correlation. I think each and everything has been covered. If still something is left, then I shall let you know. And about regression analysis, we shall inform you by tomorrow. So this is Gurpal Singh from Gursar Education. Thank you so much for joining me.